Machine vision, you know, what we've seen in the last few years is a move towards vision and automation, and we've seen a lack of labour. So a lot of what we're going to show you today is to rectify maybe the lack of labour, improve accuracy, improve throughput to your businesses. And we have a number of ways to do that, and 4 of them are called our ready solutions. So we have pack bench, forklift scanning, scan tunnel, and the dock door scan portal, which are our 4 ready solutions. We've got an example of a pack bench stroke.
So this is the issue.
Hang on a sec, go on then. Yeah, so the pack bench is a slow process and normally full of errors, or prone to error, let's not say full. But it's a concern for a lot of warehouses in the pick process. The last step of that journey, the actual pack, can be labour intensive, boring, prone to error, and repetitive. And what we're doing really, instead of just having someone with a device where they're scanning, picking something up, scanning, picking something up, we're just replacing that handheld device with a fixed scanner. So they've got 2 hands on the product. They're not putting things down, lifting things, charging things. It's not getting lost. So sorry, Adrian, we don't need Waizui for the fixed cameras.
It's gone, it's
fine. What we're seeing is that is increased throughput. And we've here, this more efficient saves 3 seconds per pack. That just depends on who's doing it. So last week we were at an event similar to this, and we actually had a pack bench that Carl had developed for the event. And depending on the skill level of the person, and bear in mind these weren't pickers or packers, some people were completing it in 20 seconds, some were completing it in 9 seconds. And it really just assisted moving the products from one side of a desk to another in a typical kind of packing solution. And every time they pack something, we'd have a light saying green, 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 these are all good. And if they picked an incorrect item, it would light red, so it was pretty obvious that it was the wrong thing. So we were able to up the throughput very quickly, and then when we gave them the hand scanner to do exactly the same pack, it would be, 10, 20 seconds, or they just give up. We can demonstrate that with this after the presentation over there. But there's a video here showing
Zebra packing bench solutions are fully optimized for modern logistics environments,
Linerless
providing
labels.
warehouse workers with a faster, streamlined experience. Our combination of fixed industrial scanning and linerless print technology saves valuable seconds on every pack, empowering frontline workers to operate 33% faster versus conventional solutions.
So that's a combination of the fixed industrial scanner as opposed to the tethered scanner or a PDA, and linerless labels where he's having to peel them or not. So, one pack we've saved 4 seconds. So just times that up by the amount of packers you've got, the amount of hours they spend in a day, and the gains, like we're looking at 33%. And 33% is a lot in any environment. And it's a really simple application, very easy to roll out. We were at an event, as I mentioned last week. We did the pack bench solution. We were in a warehouse for a quite well-known, very large next day delivery company. They asked if we could test it downstairs. Carl destroyed our demo, took the camera downstairs, and they were up and running on their actual packing line in half an hour. Was it you were back?
Yeah.
About half an hour, and they were using it live. So we basically went to an event like that and implemented a POC before we left. And they're still using it now. And yeah,
they won't give it back.
Yeah, no, well, we basically have lost that camera. So yeah, that's the first one, and probably the one that's driven quite the most interest from a fixed industrial perspective.
Next one.
The second one, similar principle. Forklift driver, rather than leaning in and out of a truck or reaching out, jumping in and out of a truck with a device. These are notorious for being smashed if you're in this environment, because the guys have always putting them on the truck, putting them off the truck. Fixing the camera to the forks. Obviously, this will depend on, correct labeling and things like that, but being able to drive up to it, scan, not get out, know exactly what's happening. All this information, again, is just being fed back to your host system, your WMS, because it's just the same as scanning as if they had a device in their hand. And again, we've got a really quick forklift driver on the video on the next one, haven't we? So yeah, if you play the next video.
Takes it sideways around the corner.
Yeah. I'm not saying everyone should drive like this in a warehouse, but he's good. But as it drives up, he's almost too fast. It sees the pallet, picks it up, it's registered it. It will then, on his terminal on the forklift, tell him where the next pick location is. And that's rather than, I haven't got my hands off the wheel, I'm not jumping in and out of a pallet truck, and I'm being given the instructions straight away. I've seen
One
this
more,
before.
yeah.
Yeah, you're going to see it. Okay. So,
Scan tunnel.
yeah, this is the scan tunnel. So again, this generated a lot of interest at the event we were at last week. We actually had a scan tunnel with us. Fortunately, we haven't bought it this time because it was heavy to take up 3 flights of stairs. But basically what this does is it's scanning boxes. It could be anything really going through the tunnel, but the cameras are positioned where they need to be to scan whatever the items are. So for instance, if you have one label and it could be on the side, on the top, on the side, then you need 3 cameras because depending where it is. If you've got labels on all sides, then you just need 1 camera because it's going to catch it wherever it is. And with this one, not only is it reading 2D, your normal barcodes, the cameras can OCR as well. So where we were last week, some of the boxes had liquid, some of them had oversize, and it could read the text to then filter it. None of that information was actually in the barcode, but the cameras can grab text. So best before dates, images.
Yeah, it was hazard label detection. So anything in that box that requires extra care, fragile, there's batteries in it, there's liquid in it, we can read that and then offload it to a separate conveyor where it's going to be handled manually with a person instead of a robot, for example.
I think we've got
Next
a bit of
one.
that. Yeah.
So that's the solution, and this is what it looks like.
So basically, that's just an arch, okay, with cameras on it, and you can see these packages are all shapes and sizes. Doesn't have to be a box. The technology is such that the range and the field of view can be adjusted to suit whatever products you've got. And like Carl said, we can filter it off or take an action depending on what you want to do, given the data it's reading. And from an OCR perspective, it's not hours and hours of training and grabbing data. The OCR engine in the software that we utilize, I mean, we could probably challenge you to bring an item up and it would be able to grab the OCR data straight away from the camera. There's no teaching it. We were at a site yesterday where we proved that was the case for best before and after dates. So we were talking about just grabbing a barcode, but actually we said, well, at the same time we can grab any of the information on that packet you want to extend the application or extend the information gathered and send back to the host system or alerts. So this is the last one, which is basically a dock door. Again, it works very similar to a scan tunnel, but it's for dock doors, your bays, your outload area, inbound area, number of cameras around the dock door. So when someone's picking up a pallet, it will read the pallet in or out of the movement and track it, whether it's going, outbound or I'm receiving a pallet full of goods. It can, rather than get someone then going on the shop floor and scanning around, you're not basically getting out again off of the truck, you're just driving it straight to put away if you need to. And again, another video. So pretty pretty straightforward. It's just reading everything that's going through. And it'll read it a number of times, and it will consume the data in the way you want it to, and we map it.
Does it know direction of travel?
Yeah, so what's triggering that is a photo cell down towards the bottom. So you have one at the front, one at the back, and it can only go 1, 2. Right. So trigger on, 1 on, trigger 2 on. If it goes the other way, it doesn't trigger.
I was going to say that.
Yeah.
So this part, so they're the fixed industrial scanning components, which is we call them the green camera range. And again, that uses one type of our software for grabbing information and mapping. And this is sort of the more technical side of stuff, the machine vision part, which, as Carl is the technical person and has been here 3 times longer than me, is going to talk about.
Yeah. All right. So dimensioning parcels is, honestly, it's an expensive business. You need a lot of hardware. It's normally a job for a system integrator, and they will spend months and months on R&D getting that right. And what it's doing is just telling you the size of the package, X, Y, and Z dimensions, and from that it can give you a volumetric calculation, so you can estimate weight. And I've been doing this a long time, it's a tricky application. What we're doing is we're using a 3D sensor to do the same thing. So hopefully, is there a video on this one, Marcus?
I wouldn't know, I've never seen this slide before.
All right. So that's what the 3D sensor sees. It's a 3D point cloud, and it measures depth and width from that. And from that in the software, you can say, okay, well, I want to measure from there to there, and that'll tell me it's 200 millimeters, for example. Very high speed, you can have multiple products at a time, and extremely accurate, far more than camera-based. This one is a good example of just how good our OCR tool is that Marcus mentioned. So, I don't know, you might be able to see that there's some text on there. This is a pharma packet. There's batch, lot, and expiry, which you have to have on there. And it's been embossed, and you can barely read that by eye. Our cameras can read it, and they're going to output that information to a WMS, ERP, whatever, for traceability. Ordinarily, this kind of thing would be in a barcode, but there's a lot of products out there that still aren't barcoded. It's text only. How do you trace that? You do it with OCR. So this video here shows somebody just hand presenting these products to the camera, and then it's reading them and sending the data out. So this particular application has just been ordered. I mean, this was a demo we built. We showed it to a end user, and they said, do you know what, we just want that. We want your demo multiplied up. It's for an American makeup manufacturer, and they've put them at point of sale. So when this stuff gets delivered to the end store, the people that are stocking them shelves pass it through this system to make sure it's legit. It's not grey market. That data is then checked against the manufacturer's database, and it says, yeah, that came from our factory. It didn't come from off the back of a lorry in China. So yeah, that's that one. So this is using AI, really overused word, but I mainly refer to it as deep learning. So again, parcels, we don't want this to go out to the customer. They're going to make a claim for this clearly because it's half empty. This one's been crushed. This is a good one. So in machine vision, it's very difficult to tell the difference between this by measuring, by looking at it. So we run it through a classification tool. We get 1,000 examples of good images from the customer, 1,000 examples of crushed, torn, and then everything in between is calculated by this AI classification system. It does all the work, gives you a file, you load it, and it will put them into each category automatically while it's running. So what probably would have been 6 months of R&D work with a 2D camera, that can be running in 4 or 5 hours. And wouldn't have been possible previously. So that is what a typical damage detection conveyor would look like. And there's a little video here that shows it in action. So that's a torn box on the side. And you can see the software there putting it into the classification boxes. So this one's crushed. And that red indicator there is a hard reject. So that will go out to a separate conveyor to be repacked.
To be fair, they're all going to be broken with that conveyor belt system.
Here's a good one. That'll go through. So these are the steps that it's doing, and it's maybe 5 or 6 steps to figure all this out. 5 years ago, that probably would have been 300-400 steps that somebody would have to make and test. That is it for the presentation. We're all right for time? Yeah, okay.
Questions for Carl?
All right, this is where it's going to get a bit hairy, live demo. So this is a real world use case, and we do a lot of these. Some people in this room will be more familiar than others. So point of manufacturer, this is running down a conveyor. It's round, which is already an issue for readability. And the customer wants to read the barcode, but more importantly, they want to make sure the product is the right one in the container and it's got the right date printed on it. None of that is in the barcode. So what this demo is doing, here we go, is all 3 of those. So it's reading the 2D barcode to make sure that the right outer container is on the product.
Wrong way, has it? Yeah, so 2D barcode is here.
So we read the code, we're making sure it's the right product, and we're also checking the expiry date has been printed correctly. And in this case, it has not been. Somebody's forgotten to change the date on the printer when it's going down the conveyor. So this red light is a switch output. So that could stop the line, it could warn an operator, it could send it out to a reject. It's going to tell you you've made a big mistake before it goes out the door. And this is what a good one would look like. So that's 23rd of September. That is the correct date, green output. It can carry on along the conveyor. Now, this is round, which makes OCR difficult because text in that direction, generally with other OCR software, you can't read that. We can, in any orientation, carry on reading that OCR. So for, as I said, round products, this is kind of a game changer. A little bit about OCR, I guess. So obviously barcodes are easier to read than text, but they're not always there. Sometimes they can be unreadable due to print quality. People use OCR text as a backup reading. Again, 3-4 years ago, if somebody wanted to do OCR, any machine vision application engineer would probably run a mile. It works great at a desk, but real world, the customer's got varying print quality, he changes the font, the spacing between characters, all these things cause chaos, and the read rate plummets to the point where they'll just turn it off and let everything through. This OCR that Zebra have developed is deep learning based, exactly the same as that box classification, but they've put millions and millions of examples of fonts through a classifying tool, which means there is zero setup. It will read anything you put in front of it. You don't have to train it. If there are variations, it'll just read it. It's really good. That is it. Demo successful.
Live demo. Well done.
Questions?
No, silence.
Right.
Oh, thanks, Paul.
I was going to say how fast can items be passed
It varies. So if you were only reading a little bit of text, reading one barcode, maybe 10 milliseconds you would need per scan. So 1,000 products a minute. If you're doing a lot more, you're checking the color of a product maybe, you're sending out a lot of text data, that could be 100 milliseconds.
Just a scenario where you've got it coming off on a production line pretty quickly.
Yeah.
And you're not getting it all in sync, so you're picking off 10, putting it in a box, and another 10's going along already. So you're picking off another 10 in a few seconds, and you put 20 in a box. Can it then scan 20, even though some have gone off and someone else is packing further down the line? Can you scan all 20 at once?
Yeah, so this is very close, tight, because it's a demo. Real world, this would probably be much higher because there's going to be a wide variation of product sizes. They're not just going to run this. So they might have something this big, this big, this big. If you need a wider field of view, you just go up with the scanner, basically. So 20 products, yes, scanner would be up here instead of here.
It'll scan 20 unique codes and log those 20 codes and that, yeah?
Yeah, so I've done pharma applications in the past where I've had 20 cartons in a box, and they want to make sure that all 24 of those cartons are present, but also the right medication. So it'll read the 20 2D barcodes and it will give you a red or green based on that. So you just put it in front of it, push a button, it'll read 20, and it'll say yes or no.
We have an application at the moment. It's Tetra Pak whiskey.
We're in.
Yeah, yeah. Bring them over.
It's Tetra Pak whiskey, and it's got to be, I think it's 24 in a pack, and we need to be able to scan those 24 because there's 10 people in a picking line.
Is the barcode visible? Is the barcode visible? It's face up?
Yeah, absolutely.
Yeah.
Yeah.
Easy. Bring them over, come on. Let's get it done.
Bring them over. It's a whiskey place. We'll go with that.
This is why I'm not allowed on stage.
Yeah.
Okay.
Anybody else got any alcohol-related requests?
Oh, good. Awesome.
Do you want your... jump in then? Yeah?
Thank you.
Thank you, guys. Cheers. Thank you.